Now we will be discussing about the graphical representation of a function or some important functions. uh, just the first important thing is, what is the graphical representation? What is a graphical? Okay, so this capital R. Yeah. Okay, first of all, you have I mean, in the previous video we said that a functional form is like this, where y is the dependent variable and x is the independent variable. So this is the functional form, and this is the independent variable, and this is the dependent variable. Now if you want to plot this, how to plot? Okay, just think that this is my x-axis and this is my y-axis. Simply this is x and this is y. Okay, this is x and this is y, and this is the origin. Okay, let me just extend it more. Okay, I think let me just make it more clear. Okay, so this is y-axis, this is x-axis, and okay, you can say that this is x dash and this is y dash, doesn't matter. Okay, now if this is in functional form, that means you know that for each value of x you will have some y. Now x I can choose by myself, but y is dependent on the value of x. Okay, so suppose for x equals to 0, I am getting some y equals to f of x here. For x equals to 1, I'm just trying to plot this y as a function, y as a function of x. I just want to plot this thing. Let me just have a look. Just, we don't know actually y is just f of x. That's, we don't know the exact expression of the function. So just for simplicity, I'm saying that for x equals to 0, I'm getting some value of y. Suppose here, for x equals to 1, I'm getting some value here. 2, I'm getting some value here. For 3, I'm getting some value here. For minus 1, x equals to minus 1, I'm getting some y value here, and similar way. And in between 0 and 1, I'm getting suppose for 0.5, I'm getting some value here, and in between, so I will get, see, in between 0 and 1 there are so many points, infinite points. So if I just try to point out each value of y for each value of x, then what do you think? I may get some sort of scattered point like this, or in case of, in general, whatever functions we are talking about, we will get some curve like this. I mean, if we plot each point, i will I will get some curve like this. I don't know what type of curve it will be, because uh, I don't know the exact expression of uh, f of x. That is in general I'm talking about. So in a continuous sense, I can draw a line, I can draw a curve like this. So this is the idea of the graphical representation of a function. Okay, but that will be more clear to you if I give you some examples. Okay, just if I give you some examples. For example, let me take a very basic example, that is y equals to 2x. Okay, so how to plot this? For that I need some values. I mean, suppose this is my x values, this is my y values. Now I can choose x as I want. Suppose I want to plot, suppose I'm just taking some numbers like this. Okay, now x I can choose by myself because x is the independent variable. Now for y, okay, look, what will I get? If x equals to minus 3, then y will be what? 2 times minus 3, that is minus 6. Okay, here what will I get? Minus 4, minus 2, 0. 2 times 1, what? 2, 4, 6. Fine. And yeah, there are so many points. So just I'm trying to uh, make you visualize how am I getting the graphs. So this is the y-axis, this is the x-axis. Okay, so fine. This is suppose 1, 2, 3, 4, 5, 6, and in this side minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and so on. and in this side 1 2 3 4 5, okay, 5 6, minus 1 minus 2 minus 3, okay, minus 4 minus 5 minus 6. So now I want to plot this. How will I plot? I will take, okay, for x equals to minus 3, I mean this, what am I getting? The value of y, that is minus 6. Okay, fine. So for x equals to minus 3, I'm getting some value of minus 6 here. So there will be a point. And for x equals to minus 2, I'm getting minus 4. Okay, I will get one more point here. For minus 1, I'm getting minus 2, so I'll get one more point. For 0, I'm getting 0, so no issues. Okay, for 1, I'm getting, okay, x equals to 1, I'm getting 2. Okay, for x equals to 2, I'm getting 4. And for x equals to 3, I'm getting 6. Okay, so I'm getting now. How am I plotting this? So now, okay, fine, these are some discrete points, but if I can vary x, actually I can vary x in minus infinity to plus infinity. Any point is allowed. So there will be other points, and from the distribution of the points, you can just imagine, or you can just guess that this is going to be a straight line. Okay, my, just don't go to my drawing. Okay, this will be actually a straight line. Okay, so actually my drawing is actually very bad. uh, I don't want to use any, okay, just pardon me for my drawing. Okay, this is a straight line passing through all the points. Okay, so in this way we can have some graphs of each function. So this straight line is actually representing what? This straight line is representing the function y equals to twice of x. Okay, so there is a graphical representation of this function. Okay, so okay, but one thing, in the previous video I have told you something, that for any relation to be a function, uh, each input can have, I think you can remember it, only one output. Okay, my handwriting, wow, one output. Just don't go for my handwriting. Okay, I know this is very bad, whatever. So yes, this one, each input can have only one output. Hmm? So what do you think? I mean, each input can have only one output. Okay, fine. Each input means what? Input means x and output means y. So for, if I have this particular value of x, I can have one value of y. Okay, in the previous video I have just showed you that how is it working, I mean with some examples. Okay, yeah. So if there is a function, suppose y equals to f of x, this is a function, and suppose I am getting some curve like this, will it be a function in reality? For checking this, what will I do? What did I say? For each value of x, I must have only one value of y, not more than one. Only one value of y. Let me check. For this value of x I'm getting, okay, for any value, for this value of x I'm getting only, for this value of x I'm getting only one value of y. Fine. For any, take any value of x, for this value of x I'm getting how many? Oh, one only. Fine. So you can say that in this graph, for each value of x I'm getting only one value of y. Are you getting my point? Okay, let me just, okay, how did I draw this line now? Say this is the x-axis, you know, I'm not just writing this again and again. This is the x-axis. So for this value of x, okay, suppose this is the value, this value is x1. So for this x1, what is the value of y? This, huh? Is there any other value of y? No, there is no value. If there must have passed through it. Are you getting my point? If there was any more than one value of y, then what should be, then the curve must have passed like this to have one more value of y, but this is not like that. So just to verify that if I'm getting only one value of y or not, just draw a parallel line to the y-axis for a particular value of x and check whether it passes through one particular point or not. I mean, it's cutting the curve at a particular value of, I mean, it's cutting the curve at a particular value or not. That's only you have to check. Okay, fine. So if now you say me something, that suppose I have a function, or not a function, or whatever, I have a relation like y equals to f of x, and the graph when I'm plotting, it's coming like this. Or It's coming like this. Oh, what happened? Yeah, this. Now tell me, is it a function? Okay, let me check for each value of x. Okay, for this value of x, yeah, only 1 point, no issues. For this value of x, only 1 point. Okay, fine. For this value of x, what happened? 1, 2, and 3 points. Done. It cannot be a function. It cannot be a function. It cannot be a function. How? Look, for this value of x, say this is x1. I am getting one y, second y, and the third y. So is this possible for a function? No. A function can have only one output for one input. But in this case, for input x equals to x1, I'm getting three outputs. So this cannot be a function. I think it's clear to you now. Okay, fine. So now just tell me one thing. Pause the video and tell me something. This is one example which can be function and which cannot be. Okay, just tell me. This is A, this is B, and this is C. And I mean, I'm not writing the details. This is x-axis, this is y-axis. You know that, na? I'm not writing again and again. Just comment in the below. Just comment that A, is it a function? Yes or no. B, is it a function? Yes or no. What is happening? Yes or no. And C, is it a function? Yes or no. Okay.